Alright everyone, so today we're going to be doing 7.3, which is going to be reciprocal functions. So to get started with this lesson, let's talk about what a reciprocal function is. So a reciprocal function, the parent function for a reciprocal function, is going to be y equals 1 over x. Knowing that, why do you think it's called the reciprocal function?
Because it's the reciprocal of the first function, which is like flip.
I mean, yeah, it's the reciprocal of a linear function, right? You're on the right track. It's the reciprocal of a linear function, y equals x, okay? And this is what it looks like. And the reason it has this interesting look to it is because of its asymptotes. It has both a vertical and a horizontal asymptote. So this is its transformation rule. All right, this is what's really important. Y equals a over x minus h plus k. So let's talk about what those different letters mean and how they affect the graph. So your a value determines your stretch, compression, and reflection over the x-axis. So if the absolute value of your a value is greater than 1, that means you have a vertical stretch, meaning the graph is going up really fast. It's stretched this way, like this, okay? Stretched this way. And if you have a vertical compression, that's when your absolute value of your a value is between 0 and 1, like 1/2, 1/3. And that means the graph is compressed this way, so it's really squished down like this. And then we have our reflection over the x-axis, which means that it's reflected over the x-axis like this. So it's basically a reflection, okay? So when you see the terminology a is less than 0, that's another way of saying that it's negative. All right, so if something's less than 0, it has to be negative, right? There's no number less than 0 that's not negative. And then the translations. So the translations are determined by your horizontal shift and your vertical shift. So these are just shifting your graph up, down, left, right. So your horizontal shift is determined by the letter h, so that's left to right. And your vertical shift is determined by your k value, which is up and down. So let's talk about what we call this. This is called a hyperbola. Have you heard that before? We've probably heard it in English class, like a hyperbole, but it's hyperbola. And then we have how to find our vertical asymptote and our horizontal asymptote. To find your vertical asymptote, you basically take the denominator of this transformation, set it equal to 0. And to find your horizontal asymptote, it's just y equals k. And then what's really cool about this topic is there's a formula for the domain and range. So your domain is going to be determined by your vertical asymptote from -infinity to the vertical asymptote, h. Anybody remember what this symbol means with the u? Union. Good. It's called the union symbol. And it means we're basically putting those two together, and that comprises our entire domain. And then we have our range, which is going to be with our horizontal asymptote from -infinity to our horizontal asymptote union from my horizontal asymptote to the infinity. So does anybody know why we exclude, specifically we go out of our way to exclude the two asymptotes? Anybody know why? Any ideas? Why would we exclude a horizontal and vertical asymptote? By the nature of what asymptotes are. Remember, asymptotes are lava. We can't touch them. The graph does not touch them. That's why we exclude them in touching those on the domain and range. So now we're going to talk about writing reciprocal functions. So we're just going to start by coming up with the functions themselves before we get into any graphing. So the first thing I like to do is, if I'm doing a problem like this, I like to write the formula for transformation, which is y equals a over x minus h plus k. So go ahead and write that formula out. And now from here, we are going to determine what a, h, and k are. So the parent reciprocal function is translated 4 units to the right. Which kind of shift would that be? Horizontal, vertical, or stretch, compress? Horizontal. So this is going to affect your h value, horizontal, okay? And then 3 units down. That's going to affect my which one? Good, vertical, which is k. And then it's going to be reflected across the x-axis, which is what letter? A. And it's going to make my a value what? Negative. So it's going to make it negative. Now in this case it's going to be -1, and the reason we know it's -1 and not negative some other number is because they didn't mention anything else about a compression or a stretch in the vertical direction, so therefore my a value is 1, we simply make it negative. So that just tells you that your a value becomes negative, it doesn't change the actual value itself. Does that make sense? Okay, so write the equation to represent the new function, identify the asymptote. So we're going to write the equation first. The equation is going to be y equals -1 over x minus h.
How do you know the a is -1?
Because it's reflected, and that's the rule for reflection. You make the a value negative. And then down 3 units. So if my k is down, it's going to be negative, right? So down 3 units. So, does anyone have any questions about how to come up with the equation itself? Does it make sense what we did there? Now keep in mind that in the formula, the nature of the h is negative, meaning that it's going to change the sign of the h as you know it in the beginning part of the problem. Okay? So, when you're translating to the right, your h value is going to be positive. It's going to become negative in the formula. If you're translating to the left, it's negative. It's going to become positive in the formula. Now, once we've done all of that, we're going to identify our vertical asymptote and our horizontal asymptote. So your vertical asymptote is always denoted by x equals something, and your horizontal asymptote is always y equals something. Because remember, x equals a number is a vertical line, y equals a number is a horizontal line. So, how we determine this is your vertical asymptote is going to be your h value. So what was my h value? My h value was actually 4 before I plugged it in, right? Yes, it changes signs from the formula. So my h value is 4, and what was my y value? That one's just as it is, -3. So that's how you find your vertical and horizontal asymptotes. So h is the one that's tricky because it does change signs a lot depending on the context of how we're looking at it. Just keep in mind the formula, it's always backwards in the formula due to the negative sign in the formula.
So to find the vertical and horizontal asymptotes, you just take what the h and the k are?
Correct. X equals your...
For the h, it's the opposite sign, right?
It's the opposite as it would be in the formula, yes. Alright, are we ready to try the next one? So, the parent reciprocal function is translated 7 units up. That's what letter?
K.
K. 1 unit to the left. That's what value?
H.
H. And then it is vertically stretched by a factor of 2. That's what value?
A.
Good. Write an equation to represent the new function. Identify the asymptotes. So, the equation is going to be y equals 2, because your a value, over x minus, now if you're going to the left, that means you're going in the negative direction, right? Minus a -1, and then it's up, so plus 7. Now, when I subtract a -1, what's going to happen there?
I'm going to add it.
Good, it's going to become positive, okay? So if you're going to the left, it's always going to become a plus, and if you're going to the right, it's always going to become a minus at the end, in the end of the problem, once you have that formula. So you can always keep that in mind as we go through. And then it wants you to identify your vertical asymptote and your horizontal asymptote. So your vertical asymptote is always x equals your h value, okay? So what was my h value here? Good, -1. And what was my k value? 7, +7. So the only one that changes is funky is the h. So do we have any questions so far? All right, let's go ahead and try the next one. A reciprocal function has a vertical asymptote located at x equals -2 and a horizontal asymptote located at y equals 5. Write an equation that could represent this function. So as we've been going through 1 and 2, we kind of learned that the vertical and horizontal asymptote translate directly to h and k. So this right here is actually your h value, and this one right here is your what? K. And did they make any mention of a at all? No. So your a is just 1. So if the a is not mentioned, it's 1. If the k or h is not mentioned, it's 0 because they're added. The a is basically the coefficient, so that's going to be 1. So that's y equals your a value, which is implied 1, all over x minus a negative, so it becomes a plus, and then plus 5. And that would be your new equation. And we don't have to come up with the asymptotes because they were provided in the question on that one. So far, what do you think about this topic?
I mean, if this is all we're doing, yeah, that's cake. But like, I know you're about to pull something up your sleeve. Some little tricky something.
Alright, well I guess you're going to see. You ready to move on to example 4? Alright, let's try example 4. So it says here the function y equals 3 over x is translated such that the asymptotes are x equals negative 3 and y equals 4. State the equation of the translated function. So, looking at this function right here, is this the reciprocal parent function? No, not quite, because the main difference is the a value is different, right? What's the a value in this this parent function?
3.
Good. So my a value is actually 3 in the original function. So it's similar to the parent, but it has a translation in the factor of an a being 3. Okay? So now that we have that, we're going to determine the h and the k. So what would my h value be here? Based on my asymptote. Negative 3. So h is horizontal, x goes with horizontal. And if you forget, the notes have a little, in the beginning, a little descriptor of it. And then your k value would be what?
4.
4. Alright, so now we're going to set up our equation. It's going to be y equals a over x, and if your h is negative, it's going to be plus h plus 4. So what's weird and confusing about asymptotes is we're used to thinking x goes with horizontal and y goes with vertical. However, in the sense of an equation for a line, x equals a number is always a vertical line because it touches the x-axis and goes right through it, and y is always a horizontal line because it touches that axis and goes this way through it. So your horizontal asymptote will be your k, and your vertical asymptote will go with your x. So far, do you have any questions for me? Okay. Given the graph, identify the asymptotes and the end behavior. Let me zoom in here. Okay. So, to identify the asymptotes, you're really just going to look at the graph, okay? So I like to draw in my asymptotes first before I determine anything. So, horizontal asymptote has to be a line that can go on the graph that doesn't touch either graph. Now, you don't have to be like particular here. Yes, technically it's going to look like it's touching the graph. But does everybody see why the vertical or the horizontal asymptote lies right here? Yeah, it lies right here because this is the section in the graph where it can go where it doesn't touch either graph. Quote unquote touch, because yes, it looks like it's touching it. It just gets really close to it. And what would the formula for this be? Y equals -1. And now we're going to do our our vertical asymptote. So this one goes right here. Okay? And your two asymptotes will always be perpendicular to each other. Okay? They're going to form a right angle. And what would the formula of this one be? Good. X equals -2. So any questions so far on that? Okay. So now that we have that information, we can fill those in over here. Our horizontal asymptote is going to be y equals -1, and our vertical asymptote is going to be x equals -2. Now remember, your vertical asymptote is also your h value, and your horizontal asymptote is always your y value. I mean your k value. I was like, why did I say y? I was just looking at the y in like my brain. Okay, so now we're going to talk about end behavior. End behavior for these functions is pretty easy. If we look at the function on its left side, what's it doing? It's going along, and it's going along forever like this. What is it doing forever into eternity? It's going closer and closer to the asymptote, right? -1, but it never actually touches it. It's playing the do not touch you game. It's getting close, doesn't actually touch it. So yes, it is approaching -1 forever. It never is going to go above that. Okay? And then over here, what's the function doing over here?
Going to negative or positive infinity. Right?
Up and down. Is it going up and down at all?
What? No.
No, that's what we're talking about. So the function is not going to go up or down. It's just going to get closer and closer to -1. So your end behavior is going to be restricted by your asymptote. Okay? So basically the graph, what you're looking at is what's the graph doing in its future, in the left and on the right. Future, it's going, in what direction is it going, up or down? Well, this one's not really going up or down. It's going up a little bit, just closer and closer to -1. What's it approaching? And now we're going to write our equation. So for the sake of this problem, we're going to assume a is equal to 1. All right. So I just want to be explicit and clear about this because your a value changes the stretch and the compress of your graph. We're assuming the a value is 1 here when we do this problem, so we can come up with the equation. So your equation is going to be y equals your a value, which we assume to be 1, over x. And then what's going to happen, it's going to be your h value. It's negative, so it's going to be positive, plus 2, and then, yes, -1. Just like that.
I like this lesson so far.
Good. Don't speak too soon. I'm just kidding. It's not bad. You'll see. But like I said, if you don't feel comfortable doing the mental math like this, feel free to use Desmos when you're graphing this on a quiz or anything like that. So before we do anything, we need to come up with the graph itself, and they give us the function y equals h over x. So what I like to do is I think of some easy x values I can plug into this function to get some points. So what number could I plug in right here for x? That's going to give me a really nice non-fraction number here. 4, that works, okay. So let's say we plug in 4 into the equation. We're just going to write 4, comma, and then we'll plug in 4 into this equation to get the y. So that would be 8 divided by 4, which is what? 2. So that's one of the points on your graph, would be 4, 2.
And how do you know again?
How do I know what?
How do you know 4, 2 is a point?
We just picked 4. We picked a random point, plugged it in for x, and then what's 8 divided by 4?
2.
That's how we got the 2. So the 4 was picked, strictly chosen.
So I could have picked like 3.
I mean, if you want to do 8/3 as your x, y value, yes. But we tried to pick one that wasn't a decimal.
Okay.
So what you're also going to notice is, let's say we plugged in -4 instead of 4. What would 8 divided by -4 be? -2. So you're going to get -4, -2 right here. So do you start seeing a pattern here, the mirroring of the points? And you can do this with all the points on the graph. If you get 1, there's going to be a negative version of it. All right? So let's say we chose another point. Like I said, I'm just picking these at random. Let's say we plugged in 1. what's 8 divided by 1? 8, which means we also have a point, -1, -8. So 1, 8, and -1, -8.
So how do you go to graph -1, -8, like 1 and 8? Like, what made you pick that point?
Why did I pick it?
Yeah.
So the reason I pick it is because I have a fraction here, and my goal is to pick a point that's going to make it not a fraction, like it's going to come out to be a nice whole number.
Oh.
So I'm thinking of numbers that will go into 8 evenly.
Okay.
Does that make sense?
And you're just trying to find like all the numbers and plotting them?
Yes, exactly. I'm just trying to find a few so I can get a general picture of my graph. So I have a few here, and it's probably good to pick one that's going to be between these. So what's another value that goes into 8 evenly?
2.
2. Okay, that'll work too. So we'll plug in a 2, and what's 8 divided by 2?
4.
4, which means we also have a point, -2, -4. And if you don't like the coming up with it just offhand, you can plug it in and actually see for yourself. So that's going to be 2, 4.
What do you mean you can plug it in and see for yourself? Like, see, what are you trying to see?
You can plug in -2 for yourself. 8 divided by -2 is -4, right?
So these you could just find any points.
Yep. You can plug in anything you want. If you wanted to go ahead and plug in 1 million, you can, and it would still give you a point that's on the graph. It's just not going to be that helpful. And then here's the last one I kind of want to do today. What if we plug in 8? What's 8 divided by 8?
1.
Good. And what's 8 divided by -8?
-1.
-1. So the idea here is, like I said, you can use graphing software to do this too. This is just kind of getting us a general look at what this graph looks like. You see it now? So this is what the graph looks like. And knowing some general parent functions of types of graphs is really going to help you understand what graphs should look like. And I think that's really important when you're learning different types of math, is to know some of the general parent functions, to know what the graph should look like when it has a certain aspect to it. So now we have a general look at our graph. Like I said, you can always use a graphing software. Find and graph the asymptotes. So let's draw in our asymptotes now that we know what our graph looks like. So it looks like we have one right here. And it looks like we have one right here as well. Everybody see the asymptotes. Why they're asymptotes? They're spots that the graph never touches. And like I said, you're hand drawing this. So obviously, theoretically, it's not touching it. But your graph could touch it a little bit, and that's okay. It's just theoretically.
So for these graphs, like for all of them, do you just plug in random values for x and then solve?
Yeah, so any graph in the entire world that you want to get a sketch of, you can just plug in random values for x and get an output value.
Okay.
And that's for any graph.
So like, I guess for like, okay, so for example 7, I could say I want to plug in 2, and then I'd solve that equation, like 1 over 2 plus 4 minus 2, and then that'd give me my y value?
Correct. That would get you your y value.
Okay.
Yes, just like you're used to doing with easier graphs, it's the same exact thing we always do.
So plug in random value for x, the answer is your y.
Yes, always.
Gotcha.
Yes, it might not be helpful, but it will always be a y, a point on the graph. Yes. So like I said, I just came up with a few that would give me a sketch, but you can always just use software as well. So find and graph the asymptotes. Well, it looks like my asymptotes are y equals 0 and x equals what? 0 as well. And basically it's the x and y axis. So another name for the x-axis is y equals 0, and another name for the y-axis is x equals 0. I don't know if you knew that or not. But looking at the equation itself, would you had predicted that?
What?
Would you have predicted these asymptotes looking at the equation? Yes. Why would we have been able to predict that? Good. There's no h and k. There's no number being added or subtracted from x, and there's no k value being added or subtracted from the fraction. Does everybody see that? But there is an a value, of course. So the horizontal asymptote, I think I should have wrote it on this line. The horizontal asymptote would have been y equals 0, and the vertical was going to be x equals 0. And now they want you to find the x and y intercepts. So you can do this either algebraically or graphically. So to find the or the x-intercept, you're going to plug in 0 for y. So you can go ahead and solve this by cross-multiplying or whatever you want to do, but think about it for a second. 8 divided by some number is 0. Is that possible to divide something by something and get 0? No, so this does not exist, which makes sense on the graph, because do we ever touch the x-intercept? No, we never touch. Never touch the x-axis because it's an asymptote. We can't touch it. It's contradictory, right? So let's try the next one. So for y-intercept, we would plug in 0 for x. And can you divide by 0 in math?
Yeah. It just doesn't it give you 1?
No. You can put it to the 0 power, which would be 1. But no, you can't divide by 0 in math. So this also doesn't exist, which is also basically predicted by the graph itself, because as you can see, we don't touch the y-axis at all, right? It's lava. We can't touch it. It's an asymptote. So it would be contradictory to have a x or y intercept here. So does that make sense to you guys, what I'm saying by that? Okay. So let's try the next one.
So does that mean all that stuff we don't have to do if they don't exist? Like on the ring?
Correct. Oh, wait. You mean over here?
Yeah.
Oh, yeah, we still got to fill it out. I thought you meant we don't have to do any math over there.
No, you just said that we're going to go to the next one, so I thought you meant to.
Oh, my bad. I didn't mean to say the next one. I meant the next part.
Like, yeah.
Sorry about that. Sorry to get your hopes up.
Yeah, you got me excited.
I'm sorry.
Oh, that's it.
So, luckily we already did this step. This part is just a repeat of what we just did. So, that part is easy. Horizontal asymptote y equals vertical x equals. Okay, so what's really cool about these functions is the domain and range have a little formula. You're right in the beginning in the notes. You remember that? So the domain is negative infinity to your vertical asymptote union negative infinity vertical asymptote. Range, same thing, so they're both 0 in this case.
Okay, so it goes to the 0 is the k. It's the
Yes. So if you look at the very beginning of your notes, we have a formula for this. Your domain is from negative infinity to h union h to negative or to h to infinity, and your range, yeah, it's just the formula from the front of your notes. Oops.
So the domain is h, and then the range would be k.
Yes. Sorry that I had these backwards. I just realized I wrote these backwards because I was here we go. Sorry about that. But yes, this is just from your notes. That's just the domain and range. And the reason those are the domain and range is because it's all real numbers except for the asymptote. Basically, the graph takes on all the numbers and it just stops at that one. It doesn't have that one value for x and the y. So that's just another way of writing all real numbers except for 0. All real numbers except for 0. That's really what that is. And now we're going to talk about the transformation. So did this graph shift left or right or anything like that? Did it have an h or a k value that shifted it? But it did have an a value, right? So what does the a value do to the graph? Good. Stretch, vertical stretch. By a factor of 8. Vertical stretch by a factor of 8. And then the end behavior, it just approaches your asymptote. Yeah, 0. So it's just going to be your asymptote. So any questions about that one? All right. So before we move on, Do y'all want to take a break before we do the last two?
I say we do it.
I'm just going to quickly show you how you would type this in on Desmos, because that can be an issue as well. Y equals, and I'm looking at example 7, 1 divided by x plus 4, arrow key over, minus 2, which is going to shift it 2 units to the right. And this is what our graph's going to look like. All right. So as you can see, we have 2 points right here that are intercepts. So I'm going to graph these on my graph, and then you guys can copy them down. Oops. Why does it do that? Hang on. All right. So that is going to be it is at negative 3.50. So negative 3.50. It's going to be right between negative 4 and negative 3. And then there's also going to be a point at negative 1.50. So it's going to be right around here. So between these two.
So there's a point where and where?
Right here.
So is that like 3.5?
Negative 3.5 comma 0 and negative 1.5, I'm sorry, 0, negative 1.5. They're just at decimals, that's why I just told you what they are. So once you graph that, you're going to kind of connect it like this. Like I said, this is just a sketch. Guys, if we're going to give you a break, you guys got to get back to it, because I feel like when I give you guys a break, then you don't want to like come back to what I'm talking about. So, all right, so then this one right here is going to be like this. So like I said, graphing software all the way on this one. I don't expect you to hand graph this. The last one wasn't too bad. This one's a little bit more confusing. Okay, so now we are going to continue with this. So finding and graphing the asymptotes. So there is a way to actually just find your asymptotes looking at the actual equation itself, which is how we are going to do this. So don't worry about the graph. Let's look at the asymptote based on the equation. So your vertical asymptote is going to be x equals your h value. Now looking at this equation, what is your h value going to be? Negative 4. And what is your horizontal asymptote going to be? Negative 2. So we kind of want to adjust. My graph isn't that great. I probably shouldn't have went up so far, because it's technically going to go below the negative 4, like here. So it's going to be more like this. I kind of went up a little too high there. So it's going to look like that. And we can just write them on the respective lines. So y equals negative 2 and x equals negative 4. And now we're going to go about finding the x and y intercepts. So the way we can do this is by simply plugging in 0 for the opposite one. So x equals 1 over x plus 4 minus 2. And then we want to solve this. So the way I would recommend solving this is to add 2 to both sides. That's going to be 2 over 1 is equal to 1 over x plus 4. So I just put it over 1 to make it into a fraction. And then how could I solve this mathematically? Anyone remember?
Keep, change, flip.
You could do keep, change, flip, or we can cross multiply.
Oh, that's right.
So that's going to be 2 times x plus 4 is equal to 1. Distribute. Solve. So x is equal to negative 3.5. So my x-intercept is at negative 3.5 comma 0, which makes sense because that's what we found on our graph as well, right? What I showed you when we did the graphing software. So, like I said, that's how you can find it algebraically as well. If you don't have graphing software, well, everybody has access to Desmos, but you know what I'm saying. So that's how you find your x-intercept algebraically. you replace your y with 0. So now we're going to do our y-intercept. So how do we find a y-intercept? We replace what with 0? X. So what is 0 plus 4?
4.
Good. So 1 over 4 minus 2. So 1/4 minus 2. So 1 divided by 4 minus 2. That comes out to be 0, negative 1.75, which is what we found on the graph as well. So everybody with me on what we just did here? We just found our intercepts. All right. So now that we found our intercepts and everything, we're going to move on to the other side, which is going to be identifying the rest of these here. So identifying key features. So we just found our x-intercept and our y-intercept. You're basically just repeating what you just did over on the other side. We just found it. We're just rewriting it. And we found our horizontal asymptote to be y equals -2 and vertical to be x equals 4. Now to find your domain and range, we're simply following the formula. So the formula for domain is negative infinity, comma, your h value, and then your range is going, I keep writing it backwards, sorry. And then your range is going to be negative infinity, -2, union, -2, positive infinity. So you just follow the formula, which says you take this, but you plug in h and k. And now we're going to talk about the transformation. The easiest way to do the transformation is just to look at the equation itself. So if we zoom out and look at the equation itself, we basically go 4 units what direction? Left. Good. And then we go down how many units? 2 units. And the A value wasn't changed, so we don't have any vertical stretch, vertical compression, or reflection. Wait a minute. Oh, we found it to be -4, not +4. These are -4s, by the way. I just realized I can't see it all in one spot, so it's a negative. So our end behavior are just going to be our 2 asymptotes, which are going to be from -4 and -2. So that's how that one's going to look.